This part is about the formula of integration. So what does it mean, integration? Integration is the same as antiderivative. And the integration, there are two parts, which we're gonna see the second part in the later section. So integration has two branches. The first one is called indefinite integration. And the second part is called definite integration. Okay, what we see for this section gonna be just the indefinite integral. The difference of these two, base for the notation, it's gonna help you see the differences between these two types of the integration. Again, the integration is the antiderivative. Okay, you have the derivative, you do backward, you get the antiderivative, and that antiderivative we call the integration. And the notation from the relationship that f prime, the capital F prime equals the lowercase f. So the capital F is antiderivative of the lowercase f from the earlier definition. So for the indefinite integral, we have the notation, the integral sign. I will identify each one in a little bit, okay? Of the integrand f of x with respect to x equals the uppercase f plus the constant c. And each notation it looks like the S but stretches S letter. So this is called the integral symbol or the integral sign. Okay. And the f of x is called integrand. And the dx is differential dx. Okay. And the lowercase f, which is the integrand, related with the uppercase f with the relationship that the f prime, the uppercase f prime equals the lowercase f. And another way to say, ask yourself what function originally that the derivative is the small f function inside of the integrand. So this one is called indefinite integration form. So I'm gonna put the box around. This is the notation for the indefinite integral. For the definite integral is similar, but we're gonna see in more detail in the later section. The definite integral, you have the integral sign the same, the integrand the same with respect. When you read it, this one is called with respect to x. So that means x is the independent variable. As you see x as the input for the function f. For the definite, you're gonna have lower limit a, upper limit b. But for the indefinite, you have no number here, see, no number here, no number there. Okay, so this the difference between the definite and indefinite integral. The definite integral, another key term that you can think of, definite like define, is defined from the left end to the right end, something like that. So right now, just focus on the indefinite integral. Okay. And from this, so the function, the uppercase f is called the antiderivative. And the c is called the constant of integration. Okay, and from the first example that we just did, that we show the f and the g, as the antiderivative of the lowercase f. So we can rewrite it as the integral of the function f, which is 3x squared plus 2x with respect to x equals x to the third plus x squared plus 50, or x to the third plus x squared minus 80, depends on the lower upper limit there. But to write in general form, we can say that the integral of 3x squared plus 2x with respect to x equals, see, the common part of both f and g would be the variable terms, or x squared, no, sorry, x to the third plus x squared plus the constant of integration c. So we can rewrite the problems number one, the content in problem one, as the integration form in the relationship that the integral of the integrand 3x squared plus 2x with respect to x is x to the third plus x squared plus the constant term. Okay. Now, another one that we saw, we used it before. We know that the derivative of x squared is 2x. So we can say x, 2x is antiderivative of x squared. So what it means, sorry, this is 2x is derivative, but x squared is antiderivative of 2x. So with the information like this one, so we can write it as the integral of 2x with respect to x is x squared plus the constant c. So as we say, whatever the function that you have, the derivative of it, I mean, the function that we have x squared here, the derivative is the same as the integrand. Okay, so that's the relationship of the derivative and the antiderivative into the integral form. And now when we look at the formula, it's going to be backward process. You are allowed to use the formula card when you do the exam. This part will be in the last exam during the final week. So just feel free to put the formula on your card and make sure you know how to use them. Okay. For the formulas of the antiderivative, the first one is called constant rule, which is the integral of the constant k with respect to x equals k times x plus c. Okay, the next one, I'll explain each one in a little bit. So the power rule, power, like the power function, the integral of x to the power r with respect to x, the power is the real number, equals x to the r plus 1 divided by r plus 1, and then plus the constant of multiple, or constant of integration. The next one is exponential rule. The integral e to the kx with respect to x is e to the kx divided by k plus c. The note of this one, you see the k here, you see the k here. Okay. The next one is the logarithmic rule. The logarithmic rule is the rule involving the log form, which is the integral of 1 over x with respect to x. That turns out to be the natural log of the absolute value of the x plus the constant of integration c. And note that x cannot be 0, because if x is 0, the expression for the integrand is undefined, so we don't have to do anything, or we have nothing to do with that. And the next one, the sum or the difference rule. Would be the integral of, you have the sum of f of x plus the gx with respect to x. You're going to find the integral of the function f with respect to x plus the integral of the function g with respect to x. But if you have the difference, you do the same. You just do the difference one for each integration. And then the next one would be the constant multiple. That's similar to the one that we do for the derivative. The constant multiple, use the notation k as the coefficient of the function f of x. You can treat k as the coefficient of the integration. So for the sum, different rule, constant multiple rule, nothing much that you have to worry about the formula, but the one that you have to recognize from now on gonna be uh, the constant rule. I tend to use different colors. So got the constant rule here, the power rule, exponential rule, log rule. And what does it mean for the rule here? You again, you have to think backwards. How do you think backwards? It's from the k here is from the derivative of the kx plus c. And the x to the power r here is the derivative of x to the r plus 1 divided by r plus 1. The e to the kx is the derivative of e to the kx divided by k. The 1 over x is the derivative of the natural log absolute value of the x. Okay, so you backward, backward, backward. All right, so the one for the power, the one that I like to point out for the power, you identify the power, you add the power by 1, and you use that new power as a denominator. Okay, for the e to the power kx, identify k. Whatever you have k will be in the denominator part. For the reciprocal of x, the derivative is the natural log absolute value of the x. Absolute value sign must be included because we have to protect the domain of the natural log to be positive quantity. Cannot be zero, cannot be negative number. Okay, so we have 4 main rules to work on for the antiderivative, excuse me, or the integration. Again, integration or the antiderivative, they are the same. So integration, it's anti-differentiation. Okay. So the next one, we're gonna look at the example. For number 2, on page 2, we are on page 2 right now. So we're gonna find the following. The following, that means for each part, we see the integral sign, the x over 3 with respect to x. Integral sign means an antiderivative. So put a note here. We're gonna find antiderivative of x over 3. Okay, integration, or we say it as the integral of x over 3 with respect to x. And this one based on the rule. So I'm gonna go to the rule on the other side and then see if I can copy them all here. So Control C and Control V. Oh, it didn't come. It didn't go. So anyway, I'm gonna go back and forth and refer to the formula. If you have the notes with you, you just look at the box above the problems. Okay, so for 2a, integration of x over 3 with respect to x, you see the number 3 on the bottom. My technique or my suggestion to work on this problem or do it in a manageable way, x over 3 means 1 over 3 multiplied by x with respect to x. We treat it as the constant multiple. So we take 1 over 3 out of the integration. So this is integration of the x to the first power with respect to x. The first step, we treat it as the constant multiple. And then the second part, we see it as a power r equals the power form, which is the power function as x to the power r, where r equals 1. Okay. And when you look at the constant multiple rule, the integral of the k of the function with respect to x is k multiplied by the integral of the function. For the power rule, the integral of x to the power r with respect to x is x to the r plus 1 divided by r plus 1, and then plus c. Plus c, don't forget the right hand side, no integral sign. When no integral sign, that means you're going to add the constant of integration. This one is called constant of integration. All right, so from this step, we know that the r equals 1. Using the formula of the power rule, the antiderivative of the power rule is 1 over 3 x to the power 1 plus 1 divided by 1 plus 1, and then plus c. After you adjust or use the power function antiderivative, the integral sign is gone. Wherever you see the integral sign and the dx, they come together, they go away together. So the next line, if no integral sign, the dx or the differential x also disappear. So right now we apply the power rule for the antiderivative to get that term. The next part, we just simplify as much as we can and finish off the problem. Now we have 1 over 3 multiplied by x to the second over 2 plus c. And 1 over 3 times x over 2 times x squared over 2 becomes x squared over 6, or we write it as 1 over 6 times x squared plus c as the antiderivative or the integral of x over 3 with respect to x. Okay, so we finish off the problem. And how do you know that the answer is correct? So we're gonna check the answer or verify the answer by you find the derivative of 1 over 6 x to the second plus c. What do you get? 1 over 6 times 2x plus 0, because derivative of c is 0. And simplify 2 and 6 to be 1 over 3 times x. And that returns x over 3, which is the integrand for this problem. And now you are done. That means your answer is correct.